Hello, this is a quick overview of the settle HDA, which basically takes any input and calculates viable, plausible rest positions for rotations. The algorithm behind this HDA is based on this paper, which basically goes through the process of calculating these rest positions without simulating. Short version of how it works is this: we take our input model, calculate the convex hull, and then for every edge and face it calculates which way it is most likely to pivot. If we take this edge right here and look at it, it would basically pivot this way, and this is basically what happens. This edge saves this face as a next pivot step, and then this face does the same, and it's gonna slowly build a path through the object until it finds a resting face where it can't pivot anymore. So let's take a look at the settings for the settle HDA. Like I said, it's based on convex hulls. The HDA automatically calculates them. You can preview them with this toggle, but you can also pipe in your own in that second input. And then you have controls for the centroid. You can move it around, which is basically moving the center of mass, which influences how these points rotate. So if you say you want a little more rotation to the left, you can you can move the center of mass, and then it's going to rotate in that direction. And you can also set it to bounding box center or convex hull center for some variation, just some settings to play around with. Most of the time you won't need to touch these though. Next up we have the natural bias slider, which is basically a bias towards the normal rest position. And if you slide that up, it basically makes it more likely that the normal standard position will come up. Then we have a filter for the minimum probability, which basically filters out low unlikely solutions. For example, if we set that to 4%, it just filters those out. The merge adjacent orients setting is used in situations like this, where you have two orientations that are very similar, and that is because of the convex hull, which has two triangles here. And it basically found out that both of these are valid, and you can just merge them into one. We've got 17 and 13% here, and if we merge them, they turn into one at 31%. We then also have these output attributes. Probability is just the normal probability. It goes from 0 to 1, where 1 would be 100%, and 0%. You can see here 31% is this, it's 0.31. Then we have the variation attribute. Each unique rotation basically gets a variation attribute. You can see this as a normal ID, but it also gets appended to the name. So this is name based. You need to put in a name, and the variation attribute basically gets appended to the name. And then last but not least, we have the alignment attribute. This is a float that goes from -1 to 1, and it basically shows how close the rotation is to the original transformation. So this is the original orientation, and the alignment is basically 1, so it's not really rotated that much. Yeah, and the whole HDA is built with the scatter and align and attribute from pieces sub in mind. Like I said before, it outputs names, and you can just read those names as piece attributes. If you set them out to random and the weighted method to weight attribute, you can also plug in the probability and remap that to change the probability of the scattered points. What you can also do is create an orient that rotates the points along the y-axis for more variation. Yeah. But as you can see, the scatter and align with the attribute from pieces setup just takes the rotated assets and scatters them. And you can then still play around with the probability and post-process from there. And yeah, that's basically it.